You remember how in the previous lesson we learned that to show that polygons are congruent, we had to show that all the corresponding parts were congruent? Well, you're going to love today's lesson because we're going to learn some shortcuts. And here we go with the first one. It says if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So just like I have in this picture here, you see that MN is congruent to QR, and MP is congruent to QS. NP is congruent to RS. If I know all those sets of corresponding sides are congruent, then I can say that triangle MNP is congruent to triangle QRS, and we abbreviate this side postulate with SSS. And when you're using that as a reason in a proof, you can just put SSS, and I'll be perfectly happy. Okay? How about the next case? If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then those two triangles are congruent. So look here at PQS. You see this angle Q here? What it means to be an included angle is that it's between the two sets of sides. So you see how angle Q and angle X are in between the two sets of sides that are marked as congruent. Well, that's what we mean by an included angle. So in this case, we have PQ being congruent to WX. We have angle Q being congruent to angle X, and then we have side QS being congruent to side XY. And since that's the case, then we know that triangle PQS is congruent to triangle WXY, and that is the side angle side congruence postulate, and we abbreviate it SAS. And again, you can put SAS as your reason in your proof. You don't have to put postulate beside it. Okay, now we have one called angle side angle, and of course we're going to call it ASA, and it says if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So you see here we have angles, corresponding angles congruent, and we have the side that is included between those two angles. That's what included means, remember. So we got an angle A congruent to angle D. Side AC is congruent to side DF. That's the included sides. Angle C is congruent to angle F. Therefore, by this postulate, I know that triangle ABC is congruent to triangle DEF. And don't forget that your order always matters. Corresponding vertices have to be labeled in the same order in your congruent triangle statement. Okay, I think there's one more. Angle side, which we'll call appropriately enough AAS, says if two angles and a non-included side of one triangle are congruent to two angles and the non-included side of a second triangle, then the two triangles are congruent. So you see here I've got angle A congruent to angle D. I've got angle C congruent to angle F. And then I've got this non-included side because it's not between these two angles this time. BC is congruent to side EF. And because of this new postulate, I know therefore that triangle ABC is congruent to triangle DEF. So what do we have? Side, 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 angle, side, angle, side, angle, and finally angle, angle, side. So four new, well actually three are postulates, one's a theorem that we can use in proofs. Be careful. There are no angle, angle, angle postulates or no angle, side, side congruence postulate. You cannot use either one of those because they don't exist. That's not to say that all three sets of corresponding angles are not congruent, because they are. It's just that just because I know that all three sets of corresponding angles are congruent, that is not enough information to tell me that I have congruent triangles. Because think about this. What if that's an equilateral triangle? Here's another equilateral triangle, right? So I would know that all those angles would be 60 degrees, right? All the corresponding angles, so A, B, C, D, E, F. So although angle A is congruent to angle D, and angle B is congruent to angle E, and so forth, those triangles are not congruent. So be careful. No angle, 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 no angle, side, side. Okay, we got some examples here, so here we go. Are the sets of triangles below congruent? If they are, justify it and write a congruent statement. Okay, so yep, we got side, 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 right? Side, side, side. And so let's see, triangle, let's say DEF, I like to go in order when I can, is congruent to triangle. So let's see, three sides, so I'm going to go JKL. JKL. I got to make sure my corresponding vertices are lined up. D corresponds to J, E corresponds to K, and F corresponds to L. So I got it right there. Okay, how about this one? Well, I know that angle 1 is congruent to angle 2 by the vertical angles theorem. So yes, these are congruent by side angle side because the angle is included. So let's see, I'm going to have triangle STY is going to be congruent to triangle, so S to T and then T to Y, so WXY. Make sure the order is correct, otherwise you'll get it wrong. All right, let's see what we got here. Okay, I know that I got congruent angles there because they're right angles and all right angles are congruent. What else do I know? I know that EG is congruent to itself, but that's really all I know, isn't it? I don't know that FG is congruent to HG or the other two sides, so no, not enough info. Not enough. They may be congruent, but not enough info to know. Okay, how about these two? So I got two sets of corresponding angles, and then this side right here is congruent to itself. So yes, and that would be angle side angle, right? Because that side RQ is included. But watch this, guys. You got to be really careful, because if I name corresponding, let's just start with PQR. Let's say triangle PQR is congruent to triangle. So if I start at P and go to Q, that's from the unmarked angle to the angle with two marks. So that means I got to start at S and go to R. SR. So PQR is going to be congruent to SRQ. Got to be careful there. So look, if I were going to do this, well, we'll do plenty of these in a proof, but what you can see here is if you're looking at corresponding sides in a proof, you would have to say that QR is congruent to RQ because order matters, remember? And even though that's the same segment, it's a different side in both triangles, and we have to get the order correct. And in a proof, the reason for this would not be the reflexive property, but the symmetric property, right? If I switch the letters around, that would be the symmetric property. So gotta be careful, careful, careful. Okay, what do we got next here? Oh, we just got some proof practice. Let's see how many proofs we have here. Let me scroll down here a minute. got 3 proofs. Let's see what we want to do here. Maybe I'll do 2 and I'll save 1 for you. How about that? Well, we'll see how it goes. So let's just start this one. Statements. Reasons. I'm going to write my given first. Wx parallel to zy. Wx is congruent to zy. And my drawing's already marked, so that's nice. If it wasn't marked, I would certainly mark it myself right now. Okay, that's all I know, but of course, knowing that those 2 sides are parallel tells me a lot. So I'm going to highlight them. They're parallel. And I'm going to mark that so I don't lose sight of it. Okay, so now guys, suppose this is a transversal here. Suppose this is a transversal. Think about it. What do I know now about some angles in that picture? That's what I'm going to state next. I know that this angle here is going to be congruent to that one, right? So let's write that down. Angle XWZ is congruent to angle YZW, order matters, XWZ, YZW, and why do I know that? Because they're alternate interior angles. So alternate interior angles theorem. And I'm looking, I forgot to mark this. What am I trying to prove? I'm trying to prove that this triangle right here is congruent to this one right here. So it looks like I can use side because I got this side angle side, right? Because this side right here is going to be congruent to itself. So let's go ahead and make that statement. But look, that's WZ. So WZ is that WZ? I gotta say WZ is congruent to itself. WX. Something's wrong with my letters here. Hold on just a second. Let me erase this. I can't really even see what's going on here. Triangle WXY. Okay, WXY is not a triangle. So we gotta fix this. CYW. I'm trying to prove that WXZ. That should be a Z right there. Fix your paper. WXZ. So now that's where I got to get this side right here, right? Because then I'm going to have side, side, angle, side. So let's do this. So I can see that I go from Z to W in this one and W to Z in this one. So I got to say WZ is congruent to ZW. All right. And the reason, like I just told you, is going to be symmetric property of congruence. So that gets it for me, and I know that triangle WXZ is congruent to triangle ZYW, and that is by side, angle, side. I got that included angle there, those alternate interior angles. Okay, let's do another one, and then I'll let you do the last one by yourself. It's probably the best one anyway. Okay, here we go. Statements. Reasons. If you want to pause and try this by yourself, that's excellent. Go for it. WY is parallel to XZ, and angle Y is congruent to angle X. All that's given. So parallel lines, I'm going to highlight those like I like to do. Okay, so I've already got an angle And that's really it. They don't tell me those sides are congruent, but once again, if this is my transversal, then what do I know? I know that this angle is congruent to this angle because again, they're alternate interior angles, so I'm going to go ahead and make that my second step. Angle YWZ is going to be congruent to angle XZW. Watch your order. That's by the alternate interior angles theorem. So I got angle, angle, and that side that they share is going to give me the angle, angle side, right? So if I say that this is congruent to itself, but once again, let's see what I got. I go from Z, if I'm going from left to right, I go from Z to W, from W to Z. So I gotta use the symmetric property again. I'm going to say WZ is congruent to ZW. And that's going to be by the symmetric property of congruence. And that gives it to me, my two triangles, WYZ is congruent to triangle ZXW by angle, angle, side. It's angle, angle, side, guys, because that side is not included between the two angles. If that's confusing to you, let's talk about it in class. All right, one more, I think is all we have. So yep, I do want you to try this one. Try this one on your own. And I will have it, you know what? No, I'm not going to put the solution up. I want you to give it a try, and we'll go over it at the very beginning of class.